For the past few years, the tech industry focused on single-prompt chatbot interfaces. You ask a question, and a model gives you an answer. Today, that model is shifting toward the agentic web. This schematic shows the core of that shift. It's called headless orchestration. A central orchestrator node divides a single goal into smaller tasks and routes them to specialized autonomous worker agents that collaborate in the background. Tech companies are now looking for software engineers who can architect these multi-agent topologies. The industry demand for this specific skill has spiked overnight. But there is a bottleneck. While the industry needs these systems, a structural barrier prevents most independent engineers from learning the fundamentals. Before a developer writes their first line of agentic code, they hit a wall of technical friction. They have to manage virtual environments, resolve path conflicts, and install heavy dependencies just to get a basic script to run. Then comes the financial risk. Most frameworks require live paid API keys just to learn the basics. You're essentially paying by the minute to train yourself. This flowchart shows why that is so dangerous. If an autonomous agent hits a logic bug, it can enter a circular thought cycle. The agent repeatedly pings the API gateway to try and solve the error, and every ping costs money. Because agents work at machine speed, that cost counter can skyrocket. A simple coding error can lead to hundreds of dollars in runaway billing in just a few minutes. Between the complex setup and the fear of a massive bill, many developers stop before they even start, abandoning frameworks like LangGraph or CrewAI. Learning autonomous AI is currently a high-stakes financial gamble. It effectively restricts this technology to developers with existing corporate cloud budgets. The AI Agent Bootcamp at aiagent.org uses a different architecture designed to bypass the local machine setup entirely. This diagram shows the process. The bootcamp utilizes WebAssembly and Pyodide, technologies that allow Python code to compile and run directly inside the browser. It bypasses the traditional computer hard drive and local installation process. Inside that browser sandbox is a full Monaco editor interface. It's a VS Code tier IDE that lets you write and run code without downloading a single file. This replaces an error-prone, multi-hour environment setup with an instant, zero-friction deployment. By removing the setup friction, a developer can stop worrying about local path errors and focus entirely on the logic of the AI itself. This browser environment also solves the problem of runaway API costs. Here is the side-by-side comparison. On the left, a traditional setup sends packets to a remote cloud server with every action. On the right, our sandbox uses a self-contained data loop. It simulates the model's thinking and tool execution locally, with no connection to a paid cloud endpoint. If you trigger an infinite loop bug in both systems, the cloud server on the left generates a red billing alert. The sandbox on the right simply displays a CPU limit reached notification. Developers can now experiment with complex cyclic networks, knowing that a logic bug will only max out their local CPU for a moment, not their credit card. This strategy turns autonomous AI development from a financial liability into a safe, accessible proving ground. While the browser is a safe training ground, the end goal is always real-world enterprise deployment. This logic map shows the bridge between simulation and reality. The bootcamp provides side-by-side code blocks that map your simulated logic directly to production-ready SDKs from providers like Google. Once a developer has debugged their agent architecture in the risk-free sandbox, they can migrate that logic back to their local machine for live production. This means building autonomous networks is no longer blocked by dependencies or the fear of massive bills. By removing technical friction and financial risk, the aiagent.org bootcamp makes the agentic web accessible to a new generation of software engineers.